Hello everyone. So today we're gonna do more of simultaneous equations. We've done them in the last session. You can check that out. We have these simultaneous equation. What's special about them is we have this variable a over here, which is not a big deal. So we need to show for part A, we need to show that x equal 3. Okay, we know we're gonna do it by elimination. So in this case, if we want x, we need to eliminate y. So, and if we eliminate y, eventually we eliminate k. So this little headache here wouldn't bother us at all. So I already have minus 2ky. So if I add to it plus 2ky, eventually y is gonna be eliminated, and so will be k. So I'll just multiply the first equation by 2. Okay, so that's what I'm gonna do. 6x plus 2ky equal 16. 8 times 2. And I'll write the second one as it is. Okay, so I'll call this 1, and this one I call it 2. So 1 plus 2 will give us 6x plus x, and these two added together is simply 0, so it's nothing. And 16 plus 5. So 16 plus 5 is 21. This is 7x, and x is 21 over 7, which is eventually x equals 3. And as required, we've proved that x is equal to 3. See, simple. Given that y equal 1 over 2, determine the value of k. So we're given y, but we have to find k. So if I'm given y and x that I've already found, and I just need to find k, so either equations will be fine. Because I have 1 over 2, I'm thinking of using this one because the 2 will cancel out with the 2. You get me? So I'm just gonna write it here so for everyone to see. Okay, and now x is equal to 3, y is equal to 1 over 2. So substitution will be 3 minus 2k times 1 over 2 equals 5. So 3 minus k equals 5. That is k equal 3 minus 5, which is k equal minus 2. So k will be minus 2. In order to check, if you wanna check, you can substitute everything here. So and see if it's actually equal to 8, because this one you haven't used. You've used this one. So that's like a way to check. Always check your whether you got the right solutions for the simultaneous equation is to use the other one that you haven't used. So 3 times, what is 3 times 3 is 9, and then minus 2 times 1 over 2, which is minus 1, which is 8. So yeah, we're right. Moving on to the next question. So question 5. While it might look like it's like a hard question, it's actually easier than anything we've done so far. So we got these simultaneous equations where p and q are constant. The solution to this pair of simultaneous equations is x equal q and y equal minus 1. Find the value of p and q. And so basically we're given values of x and y. To cut down on the number of variables, the first thing I'm going to do is I'm going to replace x and y by q and minus 1 accordingly. So x being q is going to be 2q minus p times minus 1, so plus p equals 5. And for the second equation, it's going to be 4q minus 5 plus q equal 0. So we're already there. We're already there. Like it's like we're gonna focus on the second one. The second one has only one variable, so it's easy to solve. So this one, it becomes 5q, 4q plus q. and the other one goes to the other side, so q is equal to 1. Okay, so we already found 1. So now we have to find p. We're gonna use the first one, so 2q plus p equal 5. So I know that q is 1, so it becomes 2 plus p equal 5, and p equal 5 minus 2, which is p equal 3. And it might look intimidating, but once you start working on it, it's the easiest thing you would ever do. And this should sum up the lesson for today, and I shall see you in the next one. Bye!